Hi, I'm Eric Gray from VMware. In this session, you'll learn how the availability and resiliency built into the VMware Cloud on AWS infrastructure make it the perfect platform for enterprise workloads. It's an age-old problem. IT is responsible for providing reliable infrastructure for business applications, but there's so many things that can go wrong. Let's take a look at some of those right now. At the lowest level, you perhaps have a virtual machine and the virtual disks that back up that application. Virtual data can disappear, become corrupted, be inadvertently deleted. So there's so many things you need to consider to protect the virtual machine and the virtual disk. Moving up a little bit, you have a host. The virtual machines are running on that physical server. Many things can go wrong with a physical server. A power supply can die. Perhaps the operating system of the hypervisor can crash. Individual components can fail, rendering that server useless. So we need to be able to protect against a server failure. Servers are contained in racks. Those racks can fail. The racks are typically outfitted with a top-of-rack switch, maybe a power circuit or one or more power circuits that powers all the servers in that switch. If something goes wrong with that rack infrastructure, it could affect multiple hosts. So we always need to think about protecting against rack-level failures as well. And then going beyond an individual rack, you have an entire data center. Yes, data centers can fail. In fact, in the news recently, we saw about a hosting provider over in France who actually had a major fire in the data center, and this affected millions of websites. This is definitely something that needs to be considered when you're planning the availability and resiliency for your business. And some regions of the world and in the country that you're in may have special cases of disasters, regional disasters, natural disasters, things that can take out an entire area, multiple data centers even. So sometimes if your application is very critical, or if it's subject to certain compliance requirements, you need to be thinking about how you can protect against a regional outage like that. And even if all that infrastructure is running properly and just as you expect it, there are other things that can go on. Maybe the software stack that makes up that infrastructure has bugs in it, so you need to periodically apply updates and patches. Same thing with security exploits. You have to stay on top of known vulnerabilities, be aware of patches and upgrades and how to apply them so that your infrastructure does not become vulnerable to hackers or other security threats. And then finally, even if everything is running great, business is extremely successful, you may have another problem on your hands, which is making sure you have enough resources as your business expands, as more applications are brought online, as the resource demands increase. And for that, you need to be able to stay ahead of the curve, be able to add more physical hosts, more clusters to your application so they won't be starved and cause an outage. All of these things that we just talked about have to do with preventing downtime so that your business applications can deliver what your customers expect. Now, how would you go about building infrastructure for your critical applications? One approach that has been used over many years is to build it yourself. And in many cases, this is appropriate. You know what's right for your business. You have a facility, you have a data center, you're going to acquire some space perhaps. You want to choose the servers, you want to install the software, you want to hook it all up, you want to be responsible for monitoring for bugs, security vulnerabilities. You know exactly what's required for availability, for compliance, to protect against regional failures, and you can do all that using off-the-shelf software. VMware software especially accommodates all those things that we just talked about, and you can be in control of that infrastructure. But there's another way. Your business actually differentiates itself by providing services to your customers. Or if you're a partner, you provide services to your customers so that they can run applications that generate revenue by servicing their customers. And it's often more sensible for a business to focus on their own applications rather than managing infrastructure. And if you want to get out of the infrastructure management business, you can actually take on a different approach. You can trust a provider and get your infrastructure as a service. And this is exactly what VMware Cloud on AWS is. It's trusted vSphere-based software-defined data center infrastructure that you can get as a service. VMware Cloud on AWS is jointly engineered between VMware and Amazon Web Services, and it's fully managed by VMware. That means you as a customer or you as a partner don't have to worry about patching and upgrading and updating and keeping an eye on security vulnerabilities for that infrastructure layer. You can focus on things above that layer in the stack. VMware takes care of monitoring. If there's a problem with the infrastructure, if there's a problem with a host, VMware has processes in place to deal with that. And we're going to talk about that here shortly. But we're monitoring to make sure everything is running properly. Of course, VMware is very well suited to know if the stack has any known security vulnerabilities. And VMware is also really well suited to test and roll out upgrades of patches and updates needed to stay ahead of those security vulnerabilities. So you're really getting a very capable security monitoring team working for you when you trust VMware Cloud on AWS for your applications. In addition to the security vulnerabilities, of course, there's always updates that can be added to your infrastructure for new capabilities, better performance, unlock capabilities of the underlying hardware, maybe do things more efficiently, or just better accommodate your business requirements. So this software is rolled out automatically to the whole fleet by a combination of automated processes, but also it's backed up by skilled site reliability engineers in case something does go wrong. So you can trust VMware to operate your infrastructure so you can focus on your business. Now let's start talking about some of these individual pieces. The first one is going to be storage. And we're just going to start small, we're going to work our way up. You need to protect storage because this is really the crown jewels of a business. If they lose storage, if they have data loss, in some cases that is irrecoverable. They've just never be able to get it back. So we need to have a plan in place to protect our business data from loss or corruption. And all throughout this talk today, we're going to be talking about this. But the main thing I want to point out right now is with the lowest level in the stack, the virtual disks, the actual storage. Where's the data on those flash drives in the server, in the data center? Now, ideally, we could just replicate a whole bunch of copies, many copies of the data, put them on lots of different copies of lots of different instances of servers throughout the data center, perhaps replicate it to other regions, other data centers, and just make sure that we'll never have a data loss incident. However, there's a problem with that. As with most things in engineering and technology, there's always a trade-off. Storage is a finite resource. You need to make sure you're using it effectively. So you don't want to just copy data needlessly. There may be test and dev data that you don't need to back up. Or you may have other data you're using for analysis that can be regenerated from the original sources. And it doesn't need to be backed up the same way that a critical database would or other critical customer data would. So for that, we have policy-based management of storage in your VMware Cloud on AWS software-defined data center. Because it's based on vSphere and vSAN, we can take advantage of those policy-based constructs. This means you can identify the specific disks, whether they belong to a virtual machine or perhaps a modern application based on containers. You can specify how many copies of that data you want to have in your data center, how many failures you want to tolerate. So this way you can balance the need for resiliency with efficiency and not replicating things to storage if you don't need to. Now let's zoom out a little bit more than that. what if something goes wrong with a host? Well, we have VMware vSphere-based clusters. We have high availability. We can automatically restart the virtual machines on a failed host. Restart them onto the surviving nodes of the cluster. But what happens to that failed host? If there is an outage, we need to do something about it. This means we're down on our capacity right now, and that might degrade performance or not allow us to deploy new applications. So what can we do about that? Well, behind the scenes with VMware Cloud on AWS, we have processes in place to automatically remediate these host failures. So this means we can take a failed host out of the cluster, bring in a new server that's not in service. This is not something you can easily do if you're running your own data center. Most customers don't typically have a vast pool of unused server hardware ready to go and ready to add to their cluster. So that's one of the benefits of VMware Cloud on AWS is we have that scalable capacity. So we can bring a new server in and we can rebuild the data that's lost from the failed host based on the redundant copies that still survived. And then we can bring that new host into the cluster. And we can keep on going. And all this can actually happen without any customer intervention at all. This can happen with just the VMware automated processes and if necessary, those site reliability engineers to keep an eye on things. So now we know we can protect our data, we can protect against a host failure. Your virtual machines are running on those hosts. Now what do you do if you have a application that consists of multiple virtual machines, which is typical, this is the standard. So you have redundancy in your application tier. Maybe there are multiple web servers or multiple application servers, however your application is designed. You have that redundancy there. But what if multiple VMs end up on the same single host, and then that host has a problem, and that host fails? Then your redundancy at your application layer is not going to be in effect because you're going to lose too many of your web servers or app servers. So one of the things that you can do to help inform the underlying infrastructure about your application architecture is to use compute policies. And the most typical way to do this would be to specify that certain VMs should not run on the same host if possible. That can spread those web servers apart, or those database servers, or those other servers that are redundant copies of each other. Spread them across different hosts so that if you suffer a host outage, the entire application will not go down. And in fact, you may be able to do it with zero downtime without your customers even noticing that there was a problem. And this gives that auto remediation process that we just talked about a chance to replace that host and rebalance things. And there are a couple other uses for this compute policy as far as controlling which host a virtual machine runs on, but that's not as critical when it comes to planning for resiliency and availability. So now we talked a lot about the individual hosts and how to avoid putting multiple apps that are the same type on the same server. But there's another layer to consider here. What if you have multiple servers in the same rack? A rack is a construct that can also fail. You know, not the physical part of it, but typically a rack is outfitted with one or more top-of-rack switches for connectivity, one or more power circuits to provide power to all the servers in that rack. And so if something goes wrong with that rack infrastructure, you may actually have an outage that affects multiple hosts, which could severely impact your ability to provide services to your customers. Now, if you're running your own data center, it may not be very easy to have many racks so that you can spread your cluster across all those different racks. With VMware Cloud on AWS, for example, you can have up to 16 hosts in a cluster. And with on-prem vSphere, you can even have more than that, and some customers do. So it's not really feasible in many cases to put one host per rack. So this is a problem because you're putting too many things in one item that can fail. Well, the VMware Cloud on AWS, we actually have a solution for this, and it's very elegant. We take advantage of one of the AWS constructs called a partition placement group. By using this, and this is automatic, this is not something an end customer has to do or a partner has to set up for his customer. This is part of the infrastructure because of the resiliency design. The partition placement group ensures that we never build a cluster out of physical servers that are in the same rack. So if you have an 8-node cluster, we're going to request physical servers from Amazon Web Services from 8 different racks. That way, a rack outage is not going to break your cluster. Your cluster is not going to lose quorum and require manual intervention, maybe data backup restoration, or anything like that. We're going to do our best to make sure that an event that affects a rack is not going to bring the cluster down. And in many cases, this can be remedied without anyone even knowing about it. Now, if you decide to deploy multiple clusters because you're scaling up your VMware Cloud on AWS operations, then you may end up with a server from each cluster in one rack. But those don't affect each other. So if there's a rack outage, you still just have one host affected from each of those clusters. And that's not enough to damage the cluster. So we talked about VMs and hosts and racks failing, and we have solutions for all of those things. But what about if we go out even farther and look at the data center level? Yes, a data center can fail. It's obviously not something that happens regularly, but there could be a fire. There could be some kind of an event that cuts off the internet or the power to a data center and isolates it. So for that reason, for business critical applications, we recommend deploying a stretched cluster. This puts half of your hosts in a different availability zone. So you have 2 availability zones. Half your hosts are in each availability zone. And this is actually aligned with AWS best practices. If you've ever looked into how Amazon advises their customers to deploy their cloud native applications, they always recommend putting part of the app in different availability zones. So that if one of those AZs goes down, the applications can still keep running. Now, if you're familiar with Amazon at all, with AWS, you may know that Amazon would charge when you transfer data from one availability zone to another. So you might be thinking, oh, well, if I do a stretched cluster across 2 availability zones in a region, won't that cost a lot more? There may be additional cost overall, but as far as the cross AZ charges, it's going to be limited because VMware is including 10 petabytes per month of storage transfer between those 2 availability zones. So this should satisfy essentially any current use case that you may have for VMware Cloud on AWS. Now, you will have to have an even number of hosts. So you may have one extra or part of an extra host than you normally would need if you were just in a single availability zone. But the trade-off of being able to get that resiliency and protection is worth it for business critical applications. So you'll analyze that for yourself, but the stretch cluster has many benefits and in most cases is worth it for critical applications. Last thing I'll say about this is we're talking about 2 availability zones, but there's actually a 3rd availability zone in the picture, not shown on the diagram here. That 3rd availability zone hosts the witness to ensure that if one site goes down, you'll always have quorum. You won't run into a split brain problem where each side thinks it is the surviving half. Now, if you're new to VMware Cloud on AWS, or if you've used it for a while, maybe you've never set up a stretched cluster. And perhaps you're thinking, wow, it's probably a lot of extra work. I have to set up one cluster in this availability zone, and then I have to set up another cluster in another availability zone, and then I have to somehow set up the networking to make those communicate. But no, see, that's thinking using the old mindset of do it yourself, build it yourself on-prem infrastructure management. VMware Cloud on AWS is a service. We don't expect you to go and deploy 2 different sides of a cluster and connect them up and set up the networking and the routing and the replication and all that. No, it's a service. In fact, it's so simple. The next time you deploy an SDDC, all you do is check the box marked stretch cluster, and you will have a stretch cluster across 2 availability zones. That's essentially all you need to do to get that stretch cluster. Very easy. And then once you've deployed a stretch cluster, let me just give you a quick tour here. I'm looking at the interface now. As you can see, this is a 6-node stretched cluster. So if you take a look at the tree that shows the hosts, we can see there are 2 different IP networks. In VMware Cloud on AWS, the hosts are named using an IP address. We don't actually expose a host name to you as the end user. So when you're looking at the interface, this is what you'll see. You'll see IP addresses, and these are the IP addresses that you choose when you deploy. You do have control over this because you may want to fit them into your enterprise routing scheme. But if you take a look at here, you can discern that we actually have 2 groups of 3. And these are called fault domains. And if we take a look at this first host that's highlighted, and over here, you can see the fault domain is US West 2A. So this is the Amazon region and also availability zone there. Now if we click over on another host that has a different, that's clearly from a different IP network, this is a different subnet, this is in another fault domain. So this is US West 2B. So these are the 2 different sides of your stretch cluster. They're essentially in 2 different Amazon availability zones, or Amazon data centers, so that if there is a major catastrophe with one, very unlikely event, but let's plan for any possible failure if we can, one of those goes down, you can still survive because your virtual machines will be restarted onto those surviving nodes. And now we'll drill down a little bit farther. We'll take a look at what we see on the screen here is VM1. It's just a random virtual machine that was created here. And you can look at some of the settings, and you can see that those disks are set up in a RAID 1 across both of those availability zones. So you can see that the disk, that one virtual hard disk, actually has 4 different items shown when it comes to the components here. So 2 of them are in one fault domain, and they're mirrored. So that way, if this .5 server fails, no problem. You still have a complete copy of the data on the .4 server. That's no problem. But if that entire availability zone goes down, you still have 2 more copies of the data on the other side. So this virtual machine will just restart on the other side of the cluster in the surviving AZ fault domain. And over there, again, there's 2 copies, because what if you had an AZ failover and then suddenly, an unfortunate coincidence, you also had a host failure and the host was .6? No problem. We still have a full copy of that virtual disk on the .5 server. And this is a default configuration using the default policy that is available out of the box, and it's easy to use. Now, if you knew that this virtual machine didn't contain critical data, it's development stuff, and you didn't want to replicate it that many times, you could do what we talked about earlier in the session with the policy-based management and specify that you don't want as much redundancy for that. But for right now, this is the default. It works great, and this is set up to ensure that with a minimal effort on your side, you can trust the underlying infrastructure to protect your application and your data and really give you the maximum downtime, maximum uptime, preventing downtime. Now, Amazon Web Services is all over the world, and VMware Cloud on AWS is in a lot of those locations. The map on the screen, you can see where we're located. Now, there are certain items, they're marked with an asterisk. Those indicate that you cannot have a stretched cluster in those locations, and the reason for that is what I mentioned a couple minutes ago about the stretched clusters is you need that third AZ. So if an AWS region only has 2 AZs, that's not enough for us to guarantee quorum for a stretched cluster like that. We really need 3 AZs, 2 for the servers themselves and then 1 for that witness server to make sure that the right thing happens when a failure is detected. So this is what you see on the screen there is a current map. It does change from time to time based on customer demand. So you can check out the FAQ on the VMware website to find out which regions are available today. All right, so we spent a lot of time talking about the storage and the virtual machines and the hosts and the racks and all that stuff. But what about if we have a major disaster? You're talking, earthquake or a tornado, hurricane, flood, something like that. That really just wipes out a whole region, and we need to be able to keep operating if that happens. And in many industries, this is the standard and this is required for compliance. And a great way to do this is to leverage one of the 2 VMware disaster recovery services. So we've had Site Recovery Manager for many, many years. And we've adapted it to work with VMware Cloud on AWS. And you can protect your on-prem infrastructure to the cloud. This is certainly one use case. And that could protect against a disaster with your on-prem resources. But you can also use disaster recovery to replicate your environment from one VMware Cloud on AWS region to another. So this can protect against a regional failure of these cloud-hosted software-defined data centers. And actually, we have a second service so VMware Site Recovery is the name for the service that uses the tried and proven SRM technology. Our newer addition to the lineup is called VMware Cloud Disaster Recovery. And the main difference, and there are many, and we're not going to go into the details here to do it justice, but the main difference to know about here is VCDR, it really takes advantage of cloud-based storage to give you that economy. So this is, you'll have the RTO and RPO are not as critical as with the site recovery service, but you get the economy of that lower cost cloud storage. And so it just depends on your use case and your requirements, and really comes down to the RTO and RPO requirements for your business or your industry or your if you're a partner. What does your customer require? You need to offer them the right solution for their requirements to ensure they're compliant with whatever guidelines they must operate under. Beyond just replicating your site from one location to another, you really do need to go back to basics and protect your data with backups. There's just no substitute for backups. You've got to have those multiple copies, multiple points in time of your business data in case you need to go back. Perhaps there was a human error, maybe there was corruption, maybe there was a security attack that compromised the integrity of your data, and you need to be able to go back and do that. And really the only way is to make regular backups. And the good news is there are many VMware partners that offer backup products, and a lot of them are the same ones that you've been using in your data center, protecting your business applications in your on-prem data center. Most of those partners are operating in the cloud. So you can get a cloud-based backup target, and you can back up your VMware SDDC to the cloud, sometimes using EC2 instances, or maybe using S3 object storage for more long-term storage and archiving. But regardless, you can still take advantage of a high-speed connection from your VMware SDDC to other AWS services. And this is thanks to that ENI, Elastic Network Interface, that connects your SDDC networking to the rest of Amazon. And this is something that really all production software-defined data centers need to think about, is how are they going to make regular backups of that business data so that they can recover it in case there's a problem, like I was saying. And then speaking of networking, all of the redundancy and resiliency of the clusters and apps is great, but if you can't get that connection out to the internet, to your customer, to your enterprise, it's all for nothing. You're operating some kind of a service in the cloud, and you need to make sure the connectivity is reliable. VMware Cloud on AWS is based on NSXT, and there are many great things you get with that. First of all, you get NSXT capabilities like microsegmentation and VPNs and other things, but it's all built in. It's built into the service. It's ready to go right out of the box. You don't have to enable it. You don't have to add it on. You don't have to install anything. This is the default and only networking that you have in your software-defined data center. That makes it very easy for you to create additional network segments when you need to. Virtual networking rides right on top of the AWS network infrastructure. And this is proven, very mature, very reliable. So we've got our overlay with their underlay, and everything is matched up very well. Now for NSXT networking, this is a whole nother talk. We aren't going to do it justice right here, but the main thing I'll point out is there's a concept of an edge device. This is a virtual machine that runs on the host in your SDDC. That edge device has some logical routers inside, and they are sometimes called Tier 0 and Tier 1. Tier 0 is the main upstream router, and then the Tier 1s are acting as a compute gateway and a management gateway. The compute gateway is the one that is the router between all of your workload virtual machines and the rest of Amazon virtual private clouds or the internet or other places where you need to connect to. So everything goes through here. So this is a firewall. You can create rules, very easy to do, using a graphical interface or using Power CLI or other APIs. You can set up the connectivity that you want to allow. It's got some DHCP services in there or DHCP forwarding, all the things that you need to run your applications in the cloud. But it's all designed around enterprise class, highly reliable architecture concepts. So for example, there's not actually one edge device, virtual device routing this traffic. There's two, and they're in an active standby configuration. So if the physical host fails that's running that edge device, the backup can take over immediately. It doesn't have to restart. So there's actually no lag. And in fact, for certain applications, the TCP state is even replicated across those two instances constantly. So you may find that you have a failure, but your service was not interrupted at all, depending on the typical caveats of exactly what happened at that time. But it's all designed to be very reliable. And then on top of that, it again uses that Elastic Network Interface, high-speed, reliable connectivity out to the rest of the Amazon infrastructure. From there, you can connect to something called VMware Transit Connect. Perhaps you have multiple software-defined data centers, and you want to treat them more as a logical group and have connectivity between them. This is what Transit Connect can do. And that's built on a native AWS construct called AWS Transit Gateway, and it's highly reliable and built to be resilient, just like the rest of this infrastructure that we're talking about. And in this demo screenshot, what you'll see here is the management resource pool, and I wanted to show you the NSX edge components and how we've intelligently placed them on two different physical hosts in the cluster so that if there is an incident with one of these hosts, the other host will immediately be able to take over. And the manager itself that's overseeing all the management plane of that virtual networking is also present there in 3 different instances, just for even more redundancy. So we talked a lot about the various elements of the infrastructure, all the way from the virtual disk to the region and all the things in between. And everything's going great. Business is successful. If you're a partner, your customers are succeeding, and their apps are seeing increased demand. So you want to avoid another type of outage, which is being overwhelmed by too much traffic. Thanks to VMware Cloud on AWS, you don't have to worry about that. It's a service, and bringing in additional capacity is actually very easy. In fact, we allow you to automate it through something called Elastic DRS. Now, you've probably heard of VMware vSphere DRS. This allows us to move running virtual machines from one physical host to another without any downtime. So we can do this to balance out workloads. Maybe you ended up with a bunch of VMs and suddenly they have a spike in their demand and they're all on the same host. DRS can notice that and move them off to another host to balance that load and make sure you're getting the most out of that infrastructure. But what if the cluster is just running out of resources? Well, now we have another feature, Elastic DRS, and it works hand in hand with DRS. If we detect that a host is running out of a certain resource, we can bring in an additional physical machine to that cluster. And then we can let DRS take over, move some virtual machines over there, ensure all of your apps are getting enough resources. We can also downsize a cluster. So if it turns out that this was just a seasonal spike or something that happened very, very rarely, we can add some hosts. And then when that demand drops down on all these parameters, CPU, memory, storage, then we can actually remove a host. Because VMware Cloud on AWS is a service, you pay by the host an hourly rate. So there's no sense paying for all this extra capacity if you don't need it, especially if you know you can get it back very quickly. So this is one of the beauties of running your vSphere workloads in the cloud on VMware Cloud on AWS, is we can really accommodate shifts in demand. And then one of the last things I'll mention about Elastic DRS is it has some knobs. You can tune it. By default, we're only going to scale out hosts when you start running out of storage, because if your database or file-based application starts filling up your virtual storage and your physical storage starts to run out, you're going to have a really difficult time recovering from that. So we need to stay ahead of that. When we hit a certain threshold for storage utilization, we're going to add another host to this vSAN cluster so that you don't run out. That's very important. But you may have applications that demand performance, and delivering a certain SLA to your end customers is critical. And so for that, you can optimize for best performance. You can have hosts come in quicker. Or on the other side, maybe you have a development cluster. You ran out of space in your on-prem data center, you've got a new initiative, your developers are using the cloud. As long as they're able to do their work, it's okay if the hosts are a little bit overcommitted once in a while. So we'll delay that. We want to optimize for lower cost. We don't want to trigger any new host additions unless we really need to. So those are some of the things you can do. But then the last thing, and this is something new, this is a feature that is just added in the latest release of VMware Cloud on AWS. This is as of April 2021. We've added the ability to optimize for rapid scale out and allow you to specify the scale up increment. Previously, this option only allowed 4 hosts at a time as your scale up increment. So if you had a small cluster, maybe it's a pilot light of an application that's mostly idle, and then suddenly something triggers it and it needs to be able to run a lot of virtual machines in a short amount of time. We can now go up to 12. We can increase the number of hosts in that cluster by 12 very quickly. Now it's not instant, but certainly less than an hour, you can have your cluster sized all the way up to the maximum of 16, ready to accommodate anything your application is throwing at it. So that really brings us to a wrap up. We talked about a bunch of things when it comes to why VMware Cloud on AWS gives you the resiliency and availability in the infrastructure so that you don't have to worry about it and you don't have to build your application with availability integrated because your infrastructure has it. We're able to accommodate those failures in the various components. We can make sure that resources are added and removed as needed. VMware is managing the lifecycle, making sure you have the latest security fixes, the latest features, protecting you against latent bugs that might be lurking in there that you haven't encountered yet. Just making sure you're on a recent version of the software-defined data center stack. The connectivity based on NSXT has redundancy and resiliency built into it at every aspect, from the physical connections to the virtual machines running the logical routers. These are all redundant and they're ready to accommodate your demanding network scenarios. And then finally, we did talk about business continuity and a couple different flavors of that. One would be setting up a site recovery to another region, and the other being backing up your data, your business data, so that you can go back and get different points in time and restore them in case there's been human error or corruption or security incident. So those are the benefits of VMware Cloud on AWS when it comes to resiliency and availability. If you want to learn even more, we've got some more resources for you. Please check out this white paper. You can find it at the short URL on the screen there, via.vmw.com/availability. And if you go there, you'll find a download link for the white paper, and you'll also find a handy infographic. Maybe you want to have a conversation with your own customers. Maybe you're a VMware partner, or perhaps you want to talk to some of your colleagues in your organization about the benefits of moving to VMware Cloud on AWS. If they're concerned about availability and resiliency, you can bring this out. You can show them all of the features here, and this can guide your discussion in those scenarios. So if you just want to learn more, grab the white paper, read through it. It covers all the things I talked about here, and it goes into more detail, so you really have a good understanding about how all those things fit together. And that's it for the session. Again, I'm Eric Gray from VMware Cloud on AWS Technical Marketing. Please stay with us for Q&A starting right now.